Hey folks, in this video I'm going to go over the actual code implementation for a chaining-based hash table. So let's jump in. So initially I have a class, right? Obviously we need a class, separate chaining hash table. That's cool. First thing we're going to notice is we have two generics. So we have basically a generic for our key and our value. Obviously we want to be able to insert either, obviously we want to be able to use anything as a key, anything as a value. All right. Then we have our N and M, right? So we need to keep track of the size of the array, number of elements in there, right? Pretty straightforward. And then we have is we're actually constructing the array. So ST is actually our array that holds all our different values in a chaining-based hash table. Now, one thing here to note is that my types look a little bit odd. So a type is sequential search ST. Basically, this is just a list. So if you actually go back to the very first part of the section of the course, where we had introduced the idea of symbol tables, we talked about using lists and arrays, right, to do it. That's basically reusing that, right? So this is kind of like a mini symbol table right here. So basically, it's kind of a wrapper for lists, right? In that it gives us basically easy way to look up key and value because we're reusing that. So you can look if you want, right? You can basically look on the course website. On the course website, there'll be a link, right, where you can take a look at the source code for it. For now, though, it's basically just going to be think of it as a linked list with a built-in operation that can search through every node in it and then check to see when the keys match. It's really not that complicated. So yeah, just be aware of that. All right. So first thing here is I have my constructor. My constructor just basically sets up the array, and I have my default now, the one with the argument. Nice thing about the default one is that I have a nice good value here, 997, which is prime, perfect for me. So that's great. Let's look at kind of our first real piece of code here, which is the full constructor. So first thing is I take in one parameter, which is m, and that I'll just store. That's fine. I need to keep track of it. Okay. And then basically my next two lines are to construct that array. So outside here, right, this is basically the way I have to do. Well, this is a special code in Java if I want to basically create an array of objects. I'm going to create this array basically and then do some casting, and it's, in the end, it's going to basically make the generics work. Generics in Java are sometimes a little bit finicky. Just go with it, right? This is Java's obligatory. Java's a horrible programming language. Nobody should ever use it. Just go with it, right? Java doesn't make sense sometimes. For here, basically, we have to do a cast in order to make sure that it keeps the key and value generics like what they're supposed to be. So yeah, this first line basically creates a new array, right, which will store objects of this sequential search ST type, right, or class. Once we built that array, then we can go through it, right? So now we have a loop, and that loop goes and looks at every single space inside of that array, and creates a new, a sequential search ST and puts it at each position. Okay, so we've kind of filled it in. So this is like we have basically, this line that I highlighted already is equivalent of drawing this thing here, and then this line over here is the equivalent of drawing that, and then also having little arrows to indicate there is now a little blank space at each position. So yeah, so this isn't so bad. Let's see what else we got. So now we get to a little more complicated things. First thing we have is hash. And hash is basically it does the finishing touches for a hash code. So we said, right, that we go from an object, right, to a hash. Right, this is in Java, right, this will be a hash code. Hash code, right, is the function we call. And then from this, right, we go to hash itself, which is literally a function in just this implementation. Maybe I should have named it a little bit different. And this, right, then goes, of course, to our actual index, right? So there's a kind of couple of steps we need to have. Index, kind of. All right. So that, right, basically it's like we give it a key and it gives it so this method here, we give it a key and it gives us back an index into the array. Okay, that's what it does because it looks at that key, says what's your hash code. Once it has a hash code, it throws away the sign with the the bitwise and then does the modules to make it fit inside of the array. Okay, so that gets us, basically our actual index. So then how does it work inside? Get is pretty straightforward. Go to the array, use the hash function we just talked about to look up the index from the key, and then do a get operation. So get is basically just shorthand here for having a loop that looks at every element in that linked list and checks to see when the keys are the same, and then returns them if they are the same, or null if they're not. And yeah, that's all we really need to do there. For put is kind of similar. Again, we have the symbol table, actual that array of data. We go to the index that the hash knows about. Then we say we do a put there, which is basically just throw that element into that linked list. Okay, pretty straightforward. All the important stuff is happening. Well, all the real work, right, is being done here in hash code to generate the initial number, right? Then we do work here to get the index, and then basically it's managing linked lists after that, right? Because you've kind of already gotten to the correct position. All right, so this is kind of a general idea of how this thing works. Now, before we move on to other topics, I have a couple questions for you guys on this. So first of all, right, thinking about this code, you may want to, after I talk through this, pause the video and then jump back to the code. Thinking about this, right, basically, how hard would it be to implement something like delete of key here? What do you guys think? So delete of key would be a little bit hard because the problem is we're basically just having to delete an element from the, from a list, right? It's like we can use hash to jump to the right position, right? ST of hash, but then we have to loop through, right, and touch every single element inside. And eventually we're going to find one that is a match, right, and then throw it out, right? Or maybe we don't find a match, in which case we don't have to do any work. Point is, we have to go and we have to iterate through that list. We have to look at every single element. So it's going to be a little bit of work. All right. So how hard would it be to implement resize? Okay. Next question for you guys. So resize is a little tricky as well, mainly because we kind of lose information when doing that modulus. We can't, for example, do this, right? We can't say, okay, so let's say I have an array of size 4. And let's say I have a list here that stores, 1 and 10. What I can't do is basically create a new array where m is equal to something like 10. And all of a sudden say, oh, you know what, I can just copy over the stuff I already have, right? I can't do this. Because maybe if you were to remodulus everything, that one would have ended up somewhere else. That 10 would have ended up somewhere else, right? So I can't just copy across. I basically need to reinsert or re-put everything they already had. So resize is a little bit expensive. All right. If you want to take a look at this code, you can play with it a little bit. Eventually, you'll probably get quite familiar with it because you'll do some homework that is kind of making some modifications and some implementations on it. All right. So that's all I got for this video. I'll see you guys in our next discussion, which will be on basically the performance analysis for this thing.